So signs of a device that's failing, you can think of it as that a IoT device will have memory, we have CPU, we have IOs to transmit, receive information. When any of these three or all these three are full, they tend to slow down. So your response time goes down. They tend to drop processing, drop packets. You send a request, it doesn't come back sometimes. And then third, but not last, it may lock up. That blue screen of death we see in Windows, the device locks up. Now, a well-designed device will lock up and unlock itself. It might reboot itself. That's still a bad thing. Device that rebooted itself without a human intervention, a human command to reboot, is a sign that the device is overloaded, the device is failing. I should also mention that, of course, I'm not talking about hardware issues, right? The power supply going out, the temperature of the device going too high, and therefore it loses operation. But those are obviously potential issues. I'm focusing from a network standpoint. When a device is saturated, overloaded, it slows down, it drops processing, drops packets, and it might even lock up. And those can have clear signs on the network. The most common reason is a BBMD setup, right? If the two devices are on different subnets, then they need BBMD BBMD on both subnets to allow that broadcast traffic to transfer from one subnet to the other subnet, allowing them to discover each other. The second likely problem is a IP address setup problem. Your subnet mask is set up incorrectly. Your default gateway is set up incorrectly. So that can lead to two devices not being able to communicate to each other. If the communication is intermittent, it might be a network address conflict, right? You have two devices with the same IP address. You have two devices with the same device ID. So sometimes it's able to communicate with the right devices, sometimes not being able to. So to summarize, check your BBMD distribution table. Check your IP address setup at the device themselves, the subnet address, the default gateway. And last, make sure there's no address conflicts. Port mirroring, sometimes also called a span port or a sniff port. It's a feature functionality that some switches, Ethernet switches, provide. The most common reason is a BBMD setup, right? If the two devices are on different subnets, then they need BBMD BBMD on both subnets to allow that broadcast traffic to transfer from one subnet to the other subnet, allowing them to discover each other. Right? Managed Ethernet switches provide that allow you to take the traffic going in and out of a port and mirror that, transfer that, and copy that to another port, even if that other port is not part of that communication. Using that other port, you can now connect a laptop, a PC, capture the traffic that would otherwise be sent to and from the device connected to that mirroring port. Port mirror is a feature that's provided by most managed switches. There's some switches that are light managed switches or limited managed switches, or sometimes called smart switches, that have a little bit of the managed functionality, but not all of them. And that really depends from vendor to vendor. I'm not aware if in general these smart switches, not full managed switches, provide port mirroring features, but I can tell you that managed switches do provide this ability to do mirror port. Do most people have these? Yeah, I think so. I mean, if your switch is under $100, unlikely. It's likely an unmanaged switch or a very light managed switch. It likely doesn't have port mirroring. However, I should mention that port mirroring is typically seen by the security industry as a vulnerability. So port mirror is a fantastic feature, a fantastic functionality for troubleshooting. But if you don't own that switch, if you don't have direct access to manage that switch and disable that port mirror, it might be a tall ask from the IT department to enable port mirroring. So if you are having trouble discovering your devices, and I'm talking about the baseline discovery, changing the APU timeout for discovery will not help get more devices to be discovered. APU timeout is defined by the standard. It is a timer that the sender, what we call the application client, starts the moment it sends out a request. And if an acknowledgement comes back within the timer, then all is good. If no acknowledgement is received, then it will send a new request, a repeat request, to attempt again. In general, you'll get a APU timer of 6 seconds with a retry of 3. So you might get a read property, wait 6 seconds, repeat, 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 so that the longest period, you might be waiting somewhere like 24 seconds. I'm not a big fan of it. Practically 6 seconds in electronics is multiple lifetimes. There should be absolutely no reason why a system takes that long to respond. If your APU timeout, by adjusting it, actually makes the system work better, I would highly recommend you back it off again, and really get to the crux of it. Do you have too much broadcast that's causing these massive bottlenecks through your panels, your controllers, your routers, your BBMD? Because that's what you should be focusing on. Use Optigo Visual Networks to diagnose, look at where the bottlenecks are. That's what you should be fixing. We are doing this series of short videos to answer any questions you may have. If you have questions around BACnet systems, how BACnet works on OT networks, how IT and OT works in combination, send in your questions and we'll get to it. Thank you.